And so let's look at the apical four-chamber view. So you have your left atrium that empties blood via the mitral valve into your left ventricle. Here's the muscular wall. And you have over here your right ventricle and your right atrium and tricuspid valve. And we are going to we want to measure the function of the ventricle. So we want to look at the ventricle now when it is at its largest, and that would be at end diastole, when it is done filling with blood. So I'm going to include an ECG down here. We have the P wave, atrial depolarization, QRS, ventricular depolarization, T, ventricular repolarization, P, and that would be right before the QRS starts to go up. This time here would be end diastole. Again, our QRS to T, this part is systole, and then our T wave right until the QRS starts, from the end of the T to right before the QRS starts, that would be our diastole. So this frame is right at the end of diastole, when the ventricle chamber is at its largest, and I'm going to trace out inside, so I get an area, something like this. Then I'm going to rotate my probe 60 degrees and get the apical two-chamber view. So that'll look something like this, right when the valve leaflets are closing because we are at end diastole. The ventricle is just done. And let me actually shade in the left ventricular muscle for consistency with how we've drawn this so far. So LV, but from a slightly different angle at the end of diastole when it's done filling up with blood. And I'm going to trace out the inside over here in the apical two-chamber view as well. So I get another area. Now, what I can do with these two areas is I can actually combine them to get a volume. And so the shape would look something like this. You have an arc here that comes from my apical four-chamber view, and then you have another arc over here that comes from my apical two-chamber view. And these can actually be taken together to form a shape. And you can use the Simpson biplane rule that's using calculus to find to sum up a series of disks and get a volume. Let's say that the computer will calculate the volume for you. Let's say that was 100 milliliters. So that would be the end diastolic volume. By having two roughly orthogonal views, we can chart out the shape of this, the dimensions of this shape, and we can get a volume.